Right, learners, this is the first lesson of inclination. Over the next few lessons, we're going to look at different things on inclination, which is something new in grade 11. And inclination is basically the angle that goes with a line of a certain gradient. So you know the gradient is changing the steepness of the line. So a gradient of 1 will be a 45-degree angle. A gradient of a half would be a little bit less steep. So this angle will be smaller than 45. A gradient of 2 will have an angle bigger than 45. So as I change the gradient, I'm changing the steepness of the slope that I'm walking uphill, right? And then I can look also at the angle of inclination of a line to describe how steep it is instead of looking at the gradient. And there's a relationship between this. That the relationship is described by the formula tan theta is equal to the gradient. So I have 4 different scenarios of things that can work out. So the gradient of this line is m, then the angle of inclination of this line is going to be theta. If the gradient is positive, then I can just say, well, tan theta is equal to m, or m is equal to tan theta. If I want to get the theta here, I'm going to take shift tan of the gradient m, shift tan of m to get that angle theta. So this is scenario 1, right, which just uses this formula straightforward. Scenario 2 that you can encounter is if the line goes backwards, this one goes forward. If the line goes backwards, typically you'll get a negative gradient. And then if you press like here, if you press shift tan with a negative gradient value there on your calculator, you'll see that you get a negative angle, which doesn't make sense. If you think of this angle of inclination of a negative line, it's actually going to be an obtuse angle. So you need to take that negative value and add 180 to it to get this obtuse angle. So whenever the gradient is negative, scenario 2, then you're also going to get the theta by taking shift tan with your negative gradient, but then to that answer you must still add 180 to actually get the angle of inclination. And then scenario 3 and 4, special cases for perfectly horizontal and vertical lines. If the gradient is 0, that's a flat line, right, on a horizontal line, gradient 0, then you don't need to actually do anything. The theta is also 0, that angle of inclination. Or you can think of gradient 0 flat line, so the angle of inclination there will also be 0, obviously. But I mean, if you press shift tan 0, you will get 0. But if the gradient does not exist, you can't press shift tan of something that does not exist. It's not going to exist. So just also handy to know, scenario 4 is if the gradient does not exist, that happens at a perfectly vertical line. That means this angle of inclination is going to be 90 degrees. So whenever you get an error for a gradient, then you know that angle of inclination is going to be 90 degrees. Then you're not going to use this formula. You're going to use, this. And you can actually use the tan graph from trigonometry to assist you here in thinking. If the gradient is 0, the theta is also going to be 0, right? And if the gradient doesn't exist, where there's an asymptote, it's at 90, right? Where the gradient does not exist, asymptote, that happens at 90 degrees. Okay, 0 happens at 0, you have the point 0, 0, does not exist, asymptote 90 degrees. All right. Okay, so let's look at a few examples here. We are busy from the Mind Action Series textbook with exercise 3. And this is then, let's do a few examples here. Calculate, rounded off to 2 decimal places, the inclination of the line joining the points in each case. Inclination is then the angle, right, theta. So I know that tan theta is equal to the gradient. So for all of these questions, I'm first going to calculate the gradient and then make tan theta equal to the gradient. That's what I'm going to do. So let's start there at number 1a. I've got the points a 3, -1, and b -2, -3. Right, so if I calculate the gradient of this line using my gradient formula, I have difference in y over difference in x, and you can type that into your calculator. I get 2 over 5, I think. -3 plus 1 is -2 over -5 is going to be +2 over 5. So I get 2 over 5 as my gradient. So this is positive, which means I'm looking at scenario 1. Positive gradient, I can just make tan theta equal to the gradient, which is 2 over 5. So tan theta is equal to the gradient 2 over 5, and then I'm going to use my calculator to work out theta is going to be then shift tan of 2 over 5, and shift tan 2 over 5 is 21.801, so 21.8 degrees. Right, 21.8 degrees. Okay, question B is the angle of inclination between C, which is the point -5,5, and D, which is the point 2, -4. So the first thing I'm going to do is calculate the gradient of CD. So difference in y over difference in x. It's -9 over 7. And now you see this is scenario 2, where I have a negative gradient. Then I'm still going to make tan theta equal to the gradient, but I must just remember to add the 180. Right, so tan theta is equal to -9 over 7, and then theta is going to be shift tan of -9 over 7, which if you type that into your calculator, shift tan -9 over 7, you'll see that you get a 7. Okay, you'll see that you get a negative angle there. Oh, the phone light is shining. Let me just see if I can maybe make it a bit less glaring. Okay, I think that's better. All right, so I get a negative angle. So what I need to do is also take plus 180. Okay, so I have that plus 180, and then you see it gives me the obtuse angle 127.874, rounding to 87, 127.87. So I'm going to add 180 there, giving me 127.87 degrees. Okay. Question 1C is the angle of inclination between the points F, which is at 4, 5, and G, which is at 4, 9. And to work out this gradient, first I'm going to take difference in y over difference in x, and then because of this 4 minus 4, you'll get over 0, which does not exist. But if you type this in your calculator, you'll see math error. So the gradient does not exist. And this is then scenario 4. If the gradient does not exist, that means theta is 90. So I don't need to do any tan theta equal to gradient. I can just say that theta is 90 degrees, special case. All right, okay, this is a vertical line. If the gradient does not exist, it's a perfectly vertical line, meaning that angle of inclination is going to be 90 degrees. 1D is the gradient between h, which is at 7, -2, and I, which is at 5, 1. And this, when I work out the gradient of hi high, the gradient of high. Okay, I've got difference in y over difference in x, and this is negative 3 over 2. Negative 3 over 2. So negative gradients, this is case 2, where I have a negative gradient. I'm going to remember to add 180 to my angle. Right, so I have tan theta is equal to the gradient, negative 3 over 2, and then theta is going to be 180 plus the shift tan, negative 3 over 2, like that. And I can type that into my calculator, 180 plus shift tan negative 3 over 2. It gives me 123.690, rounding off to 123.69. Okay, so angle 123.69. Right, that's working out angle of inclination. Question 2 here is, you can do number E on your own. Question 2 here, I'm just going to do number A and B. You can do C, D, E on your own. This is really easy. It says calculate the gradient of a line with inclination. Right, so now they give you the theta and they want the M. So A is 135 and B is 45. So I have number 2A, tan theta is equal to the gradient. I want the gradient, and the theta that they give me here is 135 degrees. So I want the gradient. I'm just going to substitute my theta in there. So I have tan 135 is equal to my gradient, and I can just tap that into my calculator. Tan 135 is negative 1. So this gradient is negative 1. Number B is gradient is equal to tan theta, where they give me the theta angle of inclination is 45. So M is tan 45. You can just tap that into your calculator. Tan 45 is 1. So this gradient is 1. Okay, easy enough. For all of these, you just type it into your calculator. Obviously, if it gives you a math error at 90, that gradient is going to be, the inclination angle is 90, where the gradient does not exist. So if you type in tan 90, it's going to give you math error because the gradient does not exist. You're going to literally answer that. Gradient does not exist. Okay, and this is a very short lesson, but this is the first lesson on inclination. I hope you enjoyed it. Stay safe and see you in the next video.